Hello guys, I'm Saad. Today we are going to discuss another interesting topic, which is the gas turbine cycle. This is one of the basic cycles used in the aircraft engines. So the aircraft engines are basically the gas turbines which utilize this cycle to operate. What is a Brayton cycle? Brayton cycle is the principal gas turbine cycle. Why it is called a gas turbine cycle? It is because it uses gas as a working fluid. As you remember that Rankine cycle is based on liquids. Also the refrigeration cycles are based on liquids. So in Brayton cycle you are using gas as a working fluid in order to generate the work. So what are the basic components of this cycle? The basic components are, as you can see here, the compressor, the turbine, and the combustion chamber or combustor. So what's happening here is that you supply a fuel to the combustion chamber, fresh air to the compressor, the fresh air goes into the compressor, and the compressor compresses it. This compressed air then enters the combustion chamber, where you also supply the fuel and the spark is supplied and the combustion happens and the temperature of the air or the gas is raised very high. This high temperature, high pressure gas is then expanded in the turbine, and during that expansion you extract the work and exhaust gases are exhausted to the atmosphere. You can also have a closed gas cycle, and there are many other configurations of the gas cycle, but this is a very basic gas cycle. So let us go into further detail into this gas cycle. So what we can do is that we can draw a TS diagram of this cycle. T is the temperature and S is the entropy. So starting from here, where the pressure is the ambient pressure, I'm sorry, I don't know what happened here, P ambient, okay, and the temperature here is also T ambient. Here the pressure is P high, temperature is also T high. No, sorry, the temperature is not T high, but it is T intermediate. Why it's T intermediate? As you know that during compression, the temperature is raised during compression. So T, you can say intermediate, okay. After combustion, the temperature is T high, which is the highest temperature during this cycle. And the pressure here is also P high. Now, when you go to the exhaust, you see the temperature also decreases, but it's still higher than the T ambient, so we're going to say that it's going to be T, same thing happening again. So I'm going to do this again downwards. Okay, so we're going to say that it's T ambient plus some delta T, which you can say that this is a T of exhaust, temperature of the exhaust. And the pressure here is the pressure of ambient. You can have a higher pressure here, but in a closed gas cycle, not in an open air cycle. Okay, starting with the TS diagram, we see that the compression and the expansion is an isentropic process, because we're considering ideal gas cycle. So we're going to make it a straight line, in which here is the point 1, which is a fresh air. So this is the T ambient, and as you know, what we have done is that we have compressed it. Why? Because on the TS diagram, these lines show a constant pressure lines. So I'm going to draw this again because this kind of line. So these are the constant pressure lines. So the pressure is raised from the P ambient to P high. Ambient. Okay, so this is raised from P ambient to P high, which is the point 2. As you can see, what you talked before, the temperature is also increased, but it's not the maximum temperature of the cycle. So moving from 2 to 3, you experience the maximum temperature of the cycle, and the pressure remains constant. Here you get the P. This is the P high, and this is the T high. It's the highest temperature of the cycle. And this is the point 3. Now in the turbine, we consider that it's an isotropic process, and it goes straight here. The entropy during the expansion remains constant, and we get the point 4. And from here, the gases are exhausted into the atmosphere. This is the ideal gas cycle, but we can also draw an actual gas cycle on the same diagram, but the actual gas cycle is going to be something like this. First I'm going to draw, and then I'm going to explain. Okay, it's going to go up here, here, and then here. It's going to stop a little bit over here, and then it's going to go down. Okay, so what's happening is that in a non-ideal cycle, you don't get an isotropic compression, and you have to compress more in order to account for the pressure losses during combustion and during the turbine. So you compress it more than 0.2, and then you have the pressure loss which is happening in the combustion chamber, and then you get to 0.3, and then again at 0.3 you don't go straight down, but you go straight ahead, because it's not the isotropic process. So, and why I've stopped above, a little bit above, because this pressure differential is needed in order to exhaust the gases from the gas turbine. So there's a little bit of pressure differential which we have seen here. So this is a little bit higher. We can say that P exhaust is a little bit higher than the P ambient. So this is the gas turbine cycle. I hope you learned a lot regarding the gas turbine cycle. If you have any questions, leave in the comment section and I will be happy to respond. Thank you very much.